This video is on one-sided limits. So let's look at the function f of x graphed below. One thing that we can notice is that the limit as x approaches -2 of f of x does not exist. So we would write limit as x approaches -2 of f of x equals does not exist, or just does not exist for this function. However, we do see that as x is approaching -2 from the left, x is approaching a value. It happens to be, or f of x is approaching the value -2, the output -2. So what we call the left-hand limit does exist. The limit as x approaches -2 from the left of f of x is equal to -2. And we denote that left-hand limit or right-hand limit by having that superscript of either a plus or minus up in the superscript. So similarly, the limit as x approaches to -2 from the right also exists. If we look at what the function is doing as x approaches -2 from the right, it appears to be approaching some value, maybe it's -0.8 or something like that. The limit as x approaches -2 now from the right-hand side of f of x is equal to -0.8. We're approaching an output of something like -0.8 as x approaches 2 from, or -2 from the right-hand side. And again, we denote that from the right-hand side, from the left-hand side, right-hand side with a plus in the superscript, and the left-hand side with a minus in the superscript. Observe that if we look at something like the limit as x approaches 8, the limit as x approaches 8 of f of x does exist, and it's equal to the output that the function is approaching at that point. It's approaching an output that looks like +2. So the limit there does exist and is equal to +2. And that means that the limit as x approaches 8 from the left of f of x is equal to 2. And that's also equal to the limit as x approaches 8 from the right of f of x. So when the left-hand limits and right-hand limits are equal, that means that the limit overall does exist. So the limit overall exists if and only if the left-hand and right-hand limits are both equal to the same value. So let's look at another example. Let's graph the function g of x equals the absolute value of x minus 3 divided by x minus 3. And then we'll find the left and right-hand limits as x approaches 3 of this function. So first, just thinking about graphing the function g of x equals absolute value of x minus 3 divided by x minus 3. Let's just think about what that function looks like. We know that for absolute value, we know that the absolute value of y is either equal to just regular y if y is greater than or equal to 0, and negative y if y is less than 0. Why is that true? If you think about, say, the absolute value of 3, well, it's just 3, so we'd be in this situation. The absolute value of a non-negative number is just itself. Whereas if we think about the absolute value of -2, for example, what is that? It's you remove the negative sign, it's the positive version of it, so it is +2, and so the absolute value of -2 is equal to -2 is equal to +2. So that's why this expression makes sense, that the absolute value of a negative number is the negative of that negative number. Those two negatives cancel out to give you a positive. So this is one way to express what the absolute value function is doing, and that can be helpful when we're thinking about this function g of x. So g of x is equal to absolute value of x minus 3 over x minus 3. What is that equal to? Well, when x minus 3 is positive, it's equal to x minus 3 over x minus 3. And when x minus 3 is negative, that's equal to negative x minus 3 divided by x minus 3, the opposite of what's inside. And this is if x minus 3 is greater than or equal to 0, if the thing inside the absolute value is greater than or equal to 0, and this is if x minus 3 is less than 0. So we can continue to simplify that and think about what this function looks like. This is equal to, well, x minus 3 over x minus 3 is just 1, and negative x minus 3 over x minus 3 is negative 1. And when does this happen? If x minus 3 is greater than or equal to 0, we can add the 3 over to the other side. So this is for x greater than or equal to 3. And this occurs if x is less than or equal to 3. Again, just adding 3 to both sides of that inequality. And that's x less than 3, not less than or equal to 3, because the absolute value of 0 is just 0. So now we can graph this function g of x, and we see that 1, 2, 3, when x is greater than or equal to positive 3, we have an output of positive 1. And when x is less than or equal to positive 3, we have an output of negative 1. So positive 1, negative 1. Here we have an open circle because the function is not actually at that point. But after that, the function is equal to negative 1 for x less than 3. So this is the graph of our function g of x, and now we can find both the left and right-hand limits. We say that as x approaches 3 from the left-hand side, the output of the function approaches negative 1, whereas as x approaches 3 from the right-hand side, the output of the function approaches positive 1. And we could also note at this point that g of 3 is equal to 1 as well, and that the limit as x approaches 3 overall of g of x does not exist. It does not exist because there is not one single value that the function approaches as x approaches 3. Okay, let's look at one last example. For this example, I would like you to try to sketch the piecewise function defined below. F of x equals cosine of x for x less than 0, f of x equals 3 when x is between 0 and 2, and f of x equals 2x minus 1 for x greater than 2. So try to sketch that function, and then you can also find the following values, the limits as x approaches different values from the left and right-hand side, or the overall limits of f of x. So take a moment, sketch that function, and try to find those limits or determine if they exist. Okay, for sketching this function, we sketch each part of a piecewise function. So we see that this part, the first part, is valid when x is less than 0, so below x equals 0. So cosine of x, we know it starts with x equals 0 at positive 1. So this is the value positive 1. And it starts at 1 and then decreases and increases, and it's a wave function that oscillates between positive 1 and negative 1. That might not be a perfect graph, but it's supposed to oscillate between positive 1 and negative 1. These are at pi over 2 or negative pi over 2 and negative pi and so on. So that's what cosine of x looks like, and that's what the function value is equal to for x strictly less than 0. And so we see we have an open circle here because the function value is not defined as cosine of 0 at that point. The value for f of 0 is defined by the next part of the function. It's just defined as 3 for the next piece. So let's draw that piece in red. 1, 2, 3. There's an output of 3, and f of x is 3 for x between 0 and 2, and so less than or equal to 2. So that's the output of the function for x between 0 and 2, an output of positive 3. And let's draw the last piece of the function in green. So f of x is equal to 2x minus 1 for x greater than 2. So that's a linear function. This is for x greater than 2. So when, say, x equals 3, f of 3 would be 2 times 3 minus 1, that's 5. So f of 3 should be 5. 1, 2, 5. And then let's think about this function. Oh, sorry, this is f of 3. Let's think about this function. This has a slope of 2. So for every 1 it goes over, it goes up 2. So it's a linear function like that. And we see also that it will actually happen to intersect the previous part of the function right at that point. Because again, for every 1 that it goes over, it goes up 2 because there's a slope of 2. And we can verify, 2 times 2 minus 1 is 3. So the limit as x approaches 2 from the right-hand side of this function is an output of 3. So this will intersect with what the previous part of the function was doing. Okay, so now we've got our graph of this function, f of x. It's a piecewise function defined over 3 different sections. And now let's think about the limits for this function. So as x approaches 0 from the left-hand side, that's from the left-hand side from this direction, and we see that 0 left-hand side signified by the negative subscript or superscript. And we see that as x approaches 0 from the left, f of x is approaching a value of positive 1. So f of x is approaching a value of positive 1. Whereas as x approaches 0 from the right-hand side, the output of f of x is approaching a value of 3. And then we see that the limit as x approaches 0 of f of x overall does not exist because the right and left-hand limits are not equal. There's no one value being approached by the function as x approaches 0. And finally, the actual output f of 0 is equal to 3. The function is defined as f of x equals 3 at that point. For the next line, the limit as x approaches 2 from the left. As x is approaching 2 from the left-hand side, we see that the function output is approaching a value of 3. As x approaches 2 from the right-hand side, we see that the function output is also approaching an output of 3. And finally, as x approaches 2 overall, well, now that limit does exist and is equal to 3 because the function is approaching the same value from both sides. And finally, f of 2 is equal to the value 3.